Alright guys, after factorization we want to look at the null factor law, which is part of solving quadratic equations. So the null factor law is this: if we have the product of A and B, then either A equals 0 or B must equal 0 to make that true. So let's look at using this law to actually solve some of our quadratic equations. Alright, so let's take a look at this example. So we've got x multiplied by x plus 2. So therefore, what we can state is we've got the product of two things. So either x must equal 0 to make this true, or x plus 2 must equal 0. Now, x plus 2, we can solve this to find what x should equal. Therefore, x should equal negative 2. Bring it on the other side, it becomes negative 2. So what we do here is we've got two solutions. Okay, let's look at another example. What we've got here is in brackets. We've got x plus 3 multiplied by x take 1. Again, we've got two things being multiplied together. Therefore, we can state, using null factor law, x plus 3 must equal 0, or x take 1 must equal 0. And then we simply solve for x. So, again, we have x is equal to negative 3 here. And we move the negative 1 across. We have x is equal to positive 1. So again, we've got two solutions here for x, for when we're solving. Okay, so we're going to have a look at another example. We've got x plus 1 in brackets squared. So if we square root both sides, we're going to get x plus 1 is equal to 0. We solve for x, we get x is equal to negative 1. So this is an example of where we have one solution. So a perfect square produces our one solution here. Alright, another example. We've got x plus 3 in brackets multiplied by 2x take 1 in brackets. Again, we've got two things multiplied together. So x plus 3 must equal 0, or 2x take 1 must equal 0. And we simply solve for x. So x equals negative 3 here for the first one. Or, bringing the 1 across, we get 2x is equal to positive 1. And therefore divide both sides by 2. We get x is equal to a half. So again, you'll notice that we've got two solutions for x here. Alright. Again, another solution, another example that we can look at. How do we find no solution? What happens? Let's look at this example. X squared equals negative 16. So we square root both sides, and what you'll find that you can't square root a negative number. So we have no solution when we have to square root a negative number. Right, there we go. No solution. Okay, let's look at some examples. We want to solve this. X plus 2, x take 4. Nice and simple. Same aspect with the null factor law. Either x plus 2 must equal 0, or x take 4 must equal 0. Again, we simply solve for x. So we have x equals negative 2, and x is equal to positive 4. So you notice there we've got two solutions. Nice and simple. Right, let's look at the second example. So we've got 2x plus 1 in brackets multiplied by x takes 7. Two things multiplied together. Again, remember, it's equal to 0. That's our key there. So we solve 2x plus 1 is equal to 0, or x takes 7 is equal to 0. So let's solve for 2x plus 1. 2x is equal to negative 1. X is therefore equal to negative a half, or x is equal to positive 7. Two solutions. Okay, let's take a look at another example. We've got x squared plus 4x is equal to 5. Now this example is quite different. We've got positive 5. We need to move that across to get x squared plus 4x take 5 so that it's equal to 0. Now, can we use our skills of factorizing? Of course we can. X plus 5, x take 1 is equal to 0. Now we solve using null factor law. And x is equal to negative 5, and x is equal to positive 1, again with two solutions. Our next example. 2x squared is equal to 32. Okay, so maybe we could divide both sides by 2 to get x squared is equal to 16. Square root both sides to get x is equal to plus and minus square root 16, which equals plus and minus 4. Two solutions here, positive 4 and negative 4. Alright, now there is a different way of actually doing this example, so let's look at it. 2x squared take 32 is equal to 0. Therefore, factorize 2 out to get x squared take 16. Factorize x squared takes 16, and then we solve x take 4 equals 0, or x plus 4 equals 0. Now we get x equals positive 4, or x equals negative 4. Same as what we had before, plus and minus 4. So there are two ways of doing this. Okay, let's have a look at where we use some of these skills. So we've got two quadratic expressions here, quadratic equations, sorry. We've got x take 9 in brackets x plus 8, and I've left out the equals 0, there we go, and we solve for x is equal to 9, x is equal to negative 8. Now on the left hand side it's different because we've got to actually bring it across and then factorise. So in there we factorise that expression to get x takes x plus 3, then we solve for x. X takes x equals 0, x equals 6, and x equals negative 3. Okay, let's do the same again. Let's look at two different examples. Alright, so if we look at our first example on the left, we've got 2 bracket x takes 3 squared is equal to 32. And on the right hand side there we have a different one there, 3x squared plus 18x plus 27. So let's look at our left. If we divide both sides by 2, we're going to get left x takes 3 in bracket squared equals 16. Now we can square root both sides to get x takes 3 equals plus and minus 4. That's very important, remember the plus and minus. And then we solve x takes 3 is equal to positive 4, or x takes 3 is equal to negative 4. And then we solve x is equal to 7, or x is equal to negative 1. So right hand side, let's look at a factor. Let's pull the common factor of 3 out there. And then we factorise what's inside our bracket to get x plus 3 to the power of 2. And then we solve. X plus 3 must equal 0, and there's our one solution, x equals negative 3. Great example, perfect square there. Alright, let's look at some harder questions. Right, this is probably what we're really looking at. Let's look at our first example here. Alright, so we'll have x take 3 in brackets squared, all divided by 2, and is equal to 2. Now, we need to remove this fraction, so we get rid of that divide by 2 by multiplying by 2, and what we do to one side we do to both. So now we have x take 3 in brackets squared is equal to 4. Now we can square root both sides to get x take 3 is equal to plus and minus 2, and then we solve. X takes 3 equals 2, and x takes 3 is equal to negative 2, and then x is equal to 5, and x is equal to positive 1. There's our two solutions. Okay, let's look at another harder example. 3x bracket x take 5 plus 2 is equal to negative 10. This is actually not too difficult. Let's expand out our bracket there to get 3x squared. Take 15x plus 2. Let's continue it on. Well, in fact, we can actually bring that minus 10 across to get plus 10 to get 12. Now, can we pull out a common factor? Absolutely, 3, giving us x squared minus 5x plus 4. Now, it's all equal to 0. So can we factorise that? Absolutely we can. We can get x take 4 bracket x take 1. Now we've got null factor law stating x take 4 must equal 0, or x take 1 must equal 0. Therefore x equals 4, or x equals positive 1. Two solutions. Okay, let's look at our example here. We want to get rid of this fraction here, so how do we get rid of divide by x? We multiply by x. What we do to one side, we do to the other side. Now we've got to multiply both terms by x. Now let's expand out that bracket to get x squared minus 11x equals 12. Now let's bring that 12 across to our left hand side to get x squared minus 11x. Take 12 is equal to 0. Now can we factorise that? Of course we can. What we get is x take 12 and x plus 1 is equal to 0. Our null factor law then states x take 12 must equal 0, or x plus 1 must equal 0 to get x equals positive 12 and x equals negative 1. Okay, let's look at our final hard question. X plus 5 in bracket squared is equal to 3. Again, let's get rid of this 12. X plus 5 bracket squared is equal to 36. Right, we can square root both sides. We get x plus 5 is equal to plus and minus 6. And then we simply solve. Null factor law, x plus 5 is equal to 6, or x plus 5 is equal to negative 6. And then solve for x is equal to positive 1, or x is equal to negative 11.